So this is the 2016 Junior Cert Higher Level Paper 2, and it's question number 8. Part A1 says write 2 degrees 43 minutes and 5 seconds in degrees in decimal form, correct to 2 decimal places. So every degree can be divided into 60 minutes, and every minute can be divided into 60 seconds. So these are just specific divisions of degrees. So there is a function on your calculator whereby you can type this exactly as it looks into your calculator. So that's the best way to do it, and when you do that, it will give you, when you do that, you need to press the SD button, okay, which changes it to a decimal. So when you type this in and change it to a decimal using the SD button, the answer you get is 2.7180 recurring degrees. But they've asked us to correct it to 2 decimal places, so we're going to say that that's roughly equal to, well, if we're rounding it to 2 decimal places, we look at the third digit after the decimal. Does this 8 affect the one in front? Yes, because it's 5 or more. So it's going to become 2.72 degrees to 2 decimal places. Okay, part 2 says write 3.14 degrees in degrees, minutes and seconds. So again, there's a function on your calculator here using the shift function from before, where you can type 3.14 degrees in and it will give you the degrees it'll give you the answer in degrees, minutes and seconds. So when we type that in, we get 3 degrees, 8 minutes and 24 seconds. Okay, part B. The diagram shows a right angle triangle with the angle A marked. Given that the cosine of A is equal to the sine of A, show that this triangle must be isosceles. Okay, well, that's our angle there. From this angle, this side would be called the opposite. This side here would be called the adjacent. And this side here would be called the hypotenuse from the position of angle A. So the cosine of A, or the cos of A, we know cos A is the adjacent over the hypotenuse. So it's A over H. That's cos A. So cos A there, that becomes adjacent over hypotenuse. And we know that the sine of A, the sine of the same angle, is the opposite over the hypotenuse. So you should know that sine of A is opposite over hypotenuse. This is in your tables book as well. So that gives us opposite over hypotenuse. So if the adjacent over the hypotenuse, in other words the adjacent length divided by the length of the hypotenuse, is equal to the opposite length divided by the length of the same hypotenuse, well then that means that the adjacent and the opposite must be the same. So the adjacent must be equal to the opposite for that to be true. And if the adjacent is equal to the opposite, then this triangle here, in other words this opposite and the adjacent are the same, that side and that side are the same, well then now you know it's an isosceles triangle. Therefore isosceles. Okay, so part C. A right angle triangle has sides of length 7 centimeters, 24 centimeters and 25 centimeters. Find the size of the smallest angle in this triangle and give your answer correct to 1 decimal place. Okay, so I'm going to draw a sketch of the triangle. Well, the longest side will be the hypotenuse, which is 25. So if that side was 25, I'm going to imagine that this side here is the 7 and this side here is the 24. So when I do that, if that's 25 cm, That's my hypotenuse opposite the 90-degree angle on the longest side. Then I've got this 24 centimeter side here and the 7 centimeter side here. Now the smallest angle in a triangle will always be opposite the smallest side. So the smallest side is 7, so the smallest angle will be over here. Okay, so the smallest angle, if we call it x, and we want to find the size of this angle. Well, because we have the three sides, we can use sin, cos, or tan. So I'm going to use sin. I'm going to say that I know that the sin of x will be the opposite over the hypotenuse. So in my case, the sin of x here will be the opposite, which is 7, over the hypotenuse, which is the 25. So I have the sin of x is 7 over 25. Well, then the angle x will be the inverse sin, that's shift sin on your calculator, of the fraction 7 over 25. So when I put that into my calculator, I get 16.260, and on it goes degrees, but they want the answer correct to 1 decimal place. So I'm going to look to the second digit after the decimal, and I'm going to say, does this 6 affect the 2 in front? Well, yes it does. So x then will be equal to 16.3, because that 6 will knock the 2 up, so 16.3 degrees is my answer. And that's the end of question number 8.